And we're super lucky to have our next speaker here from Plantronics. Put your hands together for Senior Vice President and CTO, Joe Burton.
Well, thanks so much. I feel almost like I should have been between the last two presentations since I'm like above all the really cool home automation infrastructure, but I'm the voice side, not the video side. I don't know, but we'll talk about it in this order anyway. So for those of you that don't know, Plantronics actually is a 53-year-old audio startup out of Santa Cruz, California, just over the hill. We're the largest producer of intelligent headsets in the world. And probably the cool claim to fame for some of us is every word that's ever been said from the moon was over a Plantronics. So we know how to build headsets that actually work. And interestingly enough, an awful lot of what we do is still about building really, really great communications products, but it backs in just a couple slides to things that actually belong at this conference. First of all, 99% of what we do at Plantronics is try to recreate this. I think we all probably agree that when communications looks like this, it works, right? And there's reasons that it works. Clearly, there's an awful lot of audio going on in this scene, and the audio is certainly wideband. It's stereo. We've all got two ears. There's some echolocation going on. They're moving their head a lot. But there's a lot of other things that are going on, too, on the audio side. Even with audio, everybody in this picture has this phenomenal DSP that's available to them called the human brain. Every single one of them is turning down the air conditioner in the back of the room. They're not quite hearing the camera or the steps over there unless it gets loud enough that it should break in. It's phenomenal audio processing that goes on for all of us. And there's things that aren't audio as well. All of us as speakers, as communicators, are getting an incredible amount of non-audio cues about the people around us. I can tell that this gentleman is really, really understanding. He's giving me a lot of positive nods. Thank you. He's part of the conversation. There's other people that are maybe looking a little confused, so I'll talk a little different way in order to measure engagement. So an awful lot of what we think about at Plantronics is what do we do to restore all of the cues of conversational engagement over time and distance. So how do we restore all of those things if I were on the other end of a telephone call so I could actually see how engaged people are? Well, there's a lot of tools that are available to us all of a sudden to do that. And it starts, interestingly enough, with network convergence. And for God's sakes, I'm not going to talk about this to this crowd. But something really interesting has happened. For 100 years, we've had real-time communications on a proprietary network. We've had data for about 50 years on its own network. They have literally converged all the way to the endpoint device with voice over LTE and similar technologies over the last year or two. For the first time, we might actually be able to send real-time audio and video and real-time data feeds of what's going on simultaneously all the way from endpoint to endpoint, from wearable sensors on a person's body all the way to the next one. Now, there's just a few sensors out there in our environment too, right? About 50 billion ARM processors have been shipped, stuck on walls, put in devices sat around your house in the last few years. Several billion Intel processors, and quite a few smaller proprietary sensors. Somewhere on the order of 10 or so devices out there that could theoretically provide information, contextual information on people for every human being that's alive. Stunning, stunning, stunning amount of stuff for the NXP guy that was up here to hook up, which should excite him very much. Now, all this data is being pushed back over a relatively infinite network that's more and more wireless to a cloud with an incredible amount of storage where analytics can get a hold of it. But the question is, how can all this actually come to bear to make a communication session better, to help us all simply communicate in a different way? Well, at Plantronics, we've actually been looking at ways of actually cloud connecting wearable communications devices, pulling in sensor data from all the devices that are around us, performing analytics on it in order to create a little bit better end-to-end communication session for people. So there's a whole bunch of things that we think flows into the future of communications. It's analytics, it's next generation spatial audio, incredible amounts of cloud processing, ubiquitous networks, very exciting new standard called Web Real-Time Communications, or WebRTC, that's going to make it so every web developer can suddenly write communications apps over the next couple of years. But all these things are the technologies, but what's it actually look like? Well, our take on this is that we can do very, very interesting things in these situations. All of us find ourselves in a noisy cafe, in an airport, walking down a street, trying to have a telephone call. How many people have tried to do a business meeting, an interview, close a deal, something while in this kind of situation? Like everyone? Yep. So here's how this works in the future. Today, I take out my nifty headset if I'm into that, or I cup my cell phone by my ear, and I hope there's enough noise cancellation in this guy that the people on the other end of the call can't hear the bus, can't hear the people around me, can't hear the footsteps, and that the people around me can't hear the confidential information. What we're beginning to see is as some of the sensor nets actually come online, as the standards get there, we're in a position where we can literally start getting notification of the bus coming down the street from the sensors of either motion, microphones, or accelerometers, and start tuning the algorithms to cancel that out. We're starting to understand proximity to people around us and whether they're strangers in our company or even somebody in our work group, so we can decide whether to create audio privacy or whether to actually let them hear what's going on. We're showing the sensor on the foot down there. We've literally been playing around with, in noisy environments, being able to cancel the individual footsteps from being transmitted through to the other end. While then not providing that processing power when there's not a footstep going on. So actually synchronizing accelerometers with DSP algorithms dynamically to create next generation communication sessions. So some pretty cool stuff going on. How do we do that? Well, first of all, we build products, but we also took some of these guys and we loaded it full of sensors. This particular one, which is actually available, has a lot of stuff in it. It actually provides through APIs on mobile devices in the cloud or on a laptop, real-time orientation information in 9 axes, free fall detection, a pedometer, taps up and down, some gesture detection, voice, is it physically on or off, what devices is it close to, on and on and on and on and on. So a whole bunch of stuff we can provide straight out of these devices. And the idea of this is that we're trying to solve some particular problems around communications, but it frees people up to solve other problems too. Great example, I am the world's most enthusiastic and yet worst mountain biker that there is. So I actually wrote an application for this myself where I actually get to the top of a hill on my mountain bike and I touch the button and say, watch me. And you'll notice on here that there's free fall detection and is it on or off of my head. After I say watch me, if there's a big splat, okay, it actually plays into my ear and says, I detected a hard fall. It actually does. And it says, hit cancel in the next 30 seconds, or I'm calling your emergency number with your current location. You know, it sounds dumb, but how many people want this for your kid or your parent or yourself or for something, right? So anyway, so a lot of cool stuff here that we're beginning to work with. Now, clearly there are some considerations and questions to be sorted through as we go forward. When we have a deluge of communications data coming in, when you've got a Skype call and a link call and a Cisco phone and 3 soft phones and on and on and on, a couple of mobiles, how do we prioritize some things around directories, hierarchy, clearly data ownership around all this quantitative data? Because boy, are we generating data. We're finding some fun patterns as I wear this around the office. It turns out you can get a very, very good understanding very quickly as to whether, as to what, not a person, but what does Joe look like when he's interested? And what does Joe look like when he's faking it? And it turns out across all these different gestures, slight variances in temperature and whatnot, I can't actually fake it, and I don't think any actor could put my device on and pretend to be me. So there's some interesting security possibilities, but there's some real questions around data ownership that we need to work through. As Plantronics, we're actually not trying to work through them alone. This particular product that I showed, the wearable Concept 1, is a solution in search of a problem. So with that in mind, we're building some of our products actually as platforms. We have developer SDKs, and the idea is to get developers to come join us in the conversation and help us figure out what to do with some of these things. So everything that I just talked about is actually, there's videos of all of it, applications that have been built at hackathons on top of it, et cetera, at pltlabs.com. PLT is our stock ticker, so it seemed like a nice thing to kind of expose the labs with. And the ability to sign up to get some of this hardware, talk to us about your applications this might fit into, because frankly, we're trying to solve the audio problem and the communications problems. All of these very, very cool augmented reality possibilities out there, we're simply not going to be solving alone. It's something we want to do with the community, so we would invite you all to come over and help us out. And that's it for me. Questions?
Thank you. Great presentation. One thing that hasn't increased as rapidly as circuitry and transistor count is battery. What's your forecast and the impact for the entire wearable scene and on the body scene for battery on wearables going forward?
Yeah, it's a great question, and you're absolutely right. It is the one piece that is growing wildly slower than everything else. So, a couple things I'd say about that. We all continue to get a bit smarter. Sadly, I would say for very, very small wireless wearable devices, the 2 constraints we start with are antenna and battery, and the whole product gets built around those. So where we are today, we're actually building wearables that are maybe half as big as this, not terribly small, but half as big as this. We're able to build things that can send continuous instrumentation wirelessly for maybe 16 hours, recharge in 20 minutes, deep sleep for 6 months if it's charged and you happen to forget about it and just pull it out. Now, actually getting that to double or triple, because in a perfect world, you know, you'd like it to last all week, and then you throw it on some little charging pad for 10 minutes, and off you go. I think it's going to. I think where we're going to be right now is most of the wearables are trying to last. Non-verticals, most of the consumer wearables are trying to last about 3 days of continuous use, and then need a recharge. I think that's about where we're going to stay, because every time we get a little bit of battery, we're going to dump 2 or 3 more sensors into it. It's like it's going to stay there until you see a battery breakthrough, to be honest. Yep. And I'll be around afterwards and can answer more questions. Yeah.
Thanks very much, Joe.
Computer somewhere? All right. Yeah, thanks.